So today's learning target, I can translate word problems into a simplified ratio. I can find unit rates and use unit prices to identify better deals. And I can compare rates and unit rates and identify if rates are equivalent. So there's a lot of I can statements for today because we're taking essentially 3 lessons and squeezing it into one because they're really, really easy. They're really, really easy material. So we're taking these 3 and kind of compressing it into one. So let's talk about what a rate is first. A rate is a ratio that compares 2 different quantities that have different units. So it might be miles compared to hours. It might be a price compared to the number of bananas, that kind of thing. It's 2 different kinds of quantities of different unit rates or different units of measurement, and you're using them to make a comparison. A ratio, we've already talked about what a ratio is. A ratio is basically a fraction. It's a proportion showing a relationship between a quantity, amount, or size of 2 different things. So if we have, 120 miles over 2 hours, that would be a ratio. The rate would be a simplifying it, or a unit rate would be a simplifying it. Now, there are 3 ways that you can write a ratio. You can write it using the word to. So it could be 5 reds to 4 blues, or 9 to 6, the number 12 to the number 1. Those are using the word to. The most common form that we utilize is a fraction, where you write it as 5 reds over 4 blues, or 9 over 6, or 12 over 1. You could also use a colon. So there's the 2 dots, the 2 dots that are on top of each other. 5 reds colon 4 blues, or 9 colon 6, or 12 colon 1. Those are the 3 different ways that you can write a ratio. Again, the most common way that we write it, though, is a fraction form. Just keep that in mind. So, writing a ratio. If we have a basket of fruit contains 6 apples, 3 oranges, 4 bananas, and 2 pears. I'm going to write a ratio that is comparing the number of bananas to the number of oranges. So the first thing I want to do is I want to identify how many bananas I have in the problem. How many bananas are there in the problem? 4, right? It says it right here, 4 bananas. And then I'm going to identify how many oranges I have in the problem. How many oranges are there? 3 oranges. I've got 3 oranges. So when I'm writing this, there are 3 ways that I could write it. I could write it as the word format, 4, and then the word 2, 3. I could write it as 4 to 3. I could write it as a fraction, 4 over 3. Or I could write it with the colon. 4, and then the colon, 3. Okay, those are the different ways that I could write it. Now, I'm going to write a ratio that's comparing the number of bananas and apples to the number of oranges and pears. So I need to first combine my values. I already know how many bananas there were. How many bananas were there? 4. There were 4. How many apples are there? 6, right? There's 6 apples. So when I say I have 4 bananas and 6 apples, how much is that? 10. I need to combine those together. I'm going to add those values together, and that's going to give me 10. Okay, same thing with the oranges and the pears. I already know how many oranges I had. I had 3 oranges. Now I need to identify the number of pears that I had. How many pears did I have? 2, right? We had 2 pears. So I have 3 oranges and 2 pears. How much fruit is that? 5, right? When I add those together, that's going to give me 5. So I'm comparing 10 and 5 to each other. So I have 10 to 5. I also have 10 over 5, and I also have 10 colon 5. Now, these would not be the final answers. Why do you think I'm saying that those would not be a final answer? What else do you think I could do? If you're looking at this, what do you think that I might still be able to do? What do you think, Isaiah? Not add. Diana? Simplify. Simplify. You always want to make sure that you simplify it. Look back at our learning target. I can translate word problems into a simplified ratio. Are these simplified? No. They can still be simplified. If I simplify it, I can simplify it to a 2 to 1. How do I know it can be simplified to 2 to 1? Because they're both divisible by what? They're both divisible by 5. I can divide this by 5. I can divide this by 5. 10 divided by 5 gives me 2. 5 divided by 5 gives me 1. It's probably easier for you to see it from the fraction form. If I did 10 divided by 5, I get 2. If I do 5 divided by 5, I get 1. So I can get 2 over 1. I can get 2 to 1. I can get 2 colon 1. You want to make sure you always simplify your ratios first. Okay, for problem number 3, we're going to write a ratio that's comparing oranges to all of the fruit. Oranges to all of the fruit. How many oranges were there? 3. There were 3 oranges. What about, how many was all the fruit? How do I figure that out? Add them all together. We had 6 apples. We had 3 oranges. We had 4 bananas. We had 2 pears. How many in total do we have? 15. We have 15 in total, right? 6 plus 3 plus 4 plus 2. That's going to come out to 15 in total. So we're going to compare it. Again, we can write it as 3 to 15, 3 over 15, or 3 colon 15. Can I simplify this? Can they be simplified? What are they both divisible by? 3. They're both divisible by 3. If I divide them both by 3, it becomes a 1 to 5. Again, if you divide them both by 3, it becomes 1 to 5, or 1 over 5, or 1 colon 5. Okay? I want you to do number 4 and number 5 on your own. Do problems 4 and 5 on your own. All right, let's take a look. Again, like I said, just go ahead and we'll focus on it in fraction form. So at Northbrook Middle School, there are 252 7th graders and 10 teachers. We're going to write it as a ratio of students to teachers. Students to teachers. So that means students is going to go on the top of our fraction, which is 252. And then on the bottom of our ratio is going to be the teachers. Teachers is going to be on the bottom of the ratio. So there are 10 teachers. Okay, 252 over 10. You can type that into your calculator and see if it can be simplified. What does that simplify to? If you do 252 over 10 and then hit enter, what does it simplify to? As a fraction. You leave it as a fraction. So if we do 252 over 10 and hit enter, all you have to do is hit enter. It's going to simplify here. 126 over 5. Leave it as a fraction. 126 over 5. That's 126 students for every 5 teachers. Okay? On average, most people can read about 600 words in 3 minutes. We're going to write this as a ratio of minutes to words. Notice that they changed it. They gave it to us as words and minutes, but they want us to write it as minutes to words. So that means on the top is going to be the minutes, which happens to be 3. And then on the bottom is what we're going to put the words. which happens to be 600. So our ratio is 3 over 600. Again, when we type that into the calculator and hit enter, it simplifies to what? 1 over 200. Good. 1 over 200 is your final answer for there. You just have to type it into the calculator, hit enter, and it'll simplify it for you. Okay? Go ahead and turn it on over to the back. Turn it on over to the back of your paper. So here, this is where we're going to start identifying the rate or the unit rate of these values. So we're going to be simplifying these fractions as a value of something per something else, a unit rate. Oh, let me get this flipped over. Sorry, does anybody still need this page? Okay. You good? Okay. So flipping it over here, talking about a unit rate. A unit rate is a rate with a denominator of 1. It's a rate of a denominator of 1. So miles per hour, price per pound, those are all considered to be unit rates. It's a value per one concept, per one quantity. So during exercise, your heart rate is 675 beats in 5 minutes. We want to know how many beats per minute is your heart rate. So we're setting it up as beats per minute. Beats per minute. So that means beats is going to go on the top. Minutes is going to go on the bottom. Beats per minute. How many beats do we have in the problem? 675. We have 675 beats. How many minutes? 5 minutes. Okay, we had 675 over 5. Now here's the easy part. You always divide by the denominator, no matter what. Even if the denominator doesn't go perfectly into the value, you always divide by the denominator. So no matter what, I'm always going to divide by whatever my denominator is. So in this case, I'm dividing both by 5. What's 675 divided by 5? 135. So that comes out to 135 beats per minute. You always divide. Even if you get a decimal, it's perfectly fine. Okay, let's take a look at problem number 2. To make 4 large pizzas, Paul needs 14 cups of cheese. We want to know how much cheese does he need for 1 pizza. So we're doing cheese over pizzas. We're going to do cheese, right? Cheese to pizza. So how many cups of cheese are we dealing with so far? 14. We have 14 cups of cheese. How many pizzas are we dealing with so far? Nope. 4. 14 cups of cheese makes 4 large pizzas. Okay, so we now have it set up. It's 14 cups of cheese over 4 pizzas, and what do I always do? Just divide. What am I dividing by? By 4. I'm going to divide by 4. It's going to give me a decimal, and that's okay. What's 14 divided by 4? 3.5. So that means it's 3.5 cups of cheese per pizza. Really simple, right? 3.5 cups of cheese per pizza. Do number 3 on your own. All right, what's his speed? 48. His speed's 48. 48 miles per hour. We have 288 miles that he was driving. but it took them 6 hours to do that drive. So we're just going to take the 288 and we're going to divide it by 6, and that's going to give us 48 miles per hour. 48 miles per hour. So unit price is exactly the same thing as unit rate, except this time you're dealing with money. With the situation, you always put money on top. Always. That's a really important thing for you to remember. Money is always going to be the value that goes on top of your fraction, and the number of items or the quantity or the size is going to go on the bottom. When we are trying to identify a cheaper unit price, that represents what the better deal would be. So when we say which one's a better deal, you're looking for which one's going to cost you the least amount of money. So when you go shopping, if you look at a grocery store, they actually have these little tags below the items, and it will give you the unit price. It'll tell you how much money you're spending per ounce or per pound on an items. Because obviously if I buy a 10-ounce item versus a 20-ounce item, 20 ounces is going to cost me more money, but the price per ounce might be less. So that what that means is that in the long run, it would be cheaper for you to buy the 20-ounce item instead of buying 2 10-ounce items. Okay? So you always want to know what your price per item is going to be, what your unit price is when you're making a comparison. So let's take a look here. If you buy 3 different sizes of lemonade, you can do 12 ounces for 99 cents, 18 ounces for $1.59, or 24 ounces for $1.79. We want to know which one is the better deal. So which one is going to be the cheaper cost per ounce. So you set this up as price over the size or the item. So let's talk about the first one. We have 12 ounces for 99 cents. So again, I'm going to set it up as doing 99 cents over 12. 99 cents over 12. Now when I divide, okay, this is what this means. It means that you're going to divide. You're going to take 99 cents and you're going to divide it by 12. When you do that, you're going to get a long drawn out decimal. You're going to get 0.0825, and it would just keep going. But we need to round it to money. Remember, money only has 2 numbers behind the decimal. Only 2 numbers behind the decimal. So that means this 0.08, that's where the money value is. Anything behind it tells you how to round. So if I'm looking at this 2 right behind it, is it telling me to keep or round up? Keep. We're going to keep this. So this is going to be roughly 8 cents per ounce. Now we're going to do the same thing for the next size. The next size is 18 ounces for $1.59. So we're going to do the same exact thing. We're going to take $1.59 and we're going to divide it by 18. Right? We're going to go ahead and divide. So if I do $1.59, 1.59 divided by 18, again, that's going to come out to a non-money value, 0.0883, and that 3 is going to be repeated. Again, this first set right here, this 0.08, that's the money. So we're going to look at the number behind it to tell me if I need to keep or round. The number behind it is an 8. So am I going to keep this or round it? Round it. That means it's going to round to 9 cents, 0.09. Which one's cheaper so far? Pink or blue? Pink. Pink is cheaper so far. Even though they both started off as 0.08, but it was 0.082 versus 0.088. 0.082 is smaller than 0.088. Okay, but we still need to look at the last one. We have 24 ounces for $1.79. So we're going to do $1.79 on the top, 24 ounces on the bottom. And then, like always, like I said, we will divide. So we're going to do 1.79 divided by 24. That's going to come out to 0.07488, and then the 3 is going to repeat. Okay, again, we need to look at it as money. These first sets right here, the 0.07, that's where the money stops. So we're going to look at the number right behind it, the 4. Are we going to keep or round up? Keep. Okay, so we're going to keep this. This is going to stay 0.07. So which one is cheaper? Pink, blue, or green? Green. Green is the better deal. So I'm going to go ahead and circle this item. This is the better deal. Okay, I want you to do the same thing for problem number 2. I want you to identify which one would represent the better deal. Again, you always do price divided by the item, price divided by the size, or price divided by the quantity. Price always goes on top. All right, let's go ahead and go over this. Remember, what always goes on the top? Money, right? Price always goes on the top. The money always goes on top. So for our first value of soup, we've got $3.60 for 150 liters. So we're going to put $3.60 and we're going to divide it by 150. We do 3.60 divided by 150. That's going to come out to 0.024. Again, the 0.02 is where the money belongs. That 4 is just telling us whether we're going to keep or round. Are we going to keep or round? Keep. So this is going to stay 0.02. This is going to stay 0.02. Let's look at the next one. The next one is $3.51, and it's going to be divided by 130 liters. When we divide that, that's going to also come out to 0.02, but it's 0.027. 0.027. So when we're looking at the 0.02, that 7 is going to tell us to keep or round. Round. Right, we're going to round it up to the next one, so it becomes 0.03. Okay, then our last one, we have $7. $7 for 200 liters, so we're going to do 7 divided by 200. That's going to come out to 0.035. Again, the 0.03 is where the money is. The 5 is going to tell us to keep or round. Round. So we're going to round it to 0.04. Which one's the cheapest? Pink, blue, or green? Pink. This one's the better deal right here. That's our better deal. Always, always, always do price divided by the items. And just so you know, you have an assignment, not right now, but you're going to have an assignment today that is going to be dealing with these price versus item. Go ahead and flip your paper to the last page. Okay, so with these ones, what we're going to be doing here, we're going to be making comparisons. Some of these we're going to be setting up as actual, what we call complex fractions, where you might have a fraction inside of a fraction, and that's completely okay. You would still simplify it down to its rate per 1 unit, its unit rate. So an artist completed 1/4 of a painting in 2 weeks. We want to know what is the completion per week. How long does it take per 1 week? So we're setting it up as completion over weeks. The completion over weeks. So far they've completed 1/4 of their painting over a period of 2 weeks. So we would have the complex fraction 1/4 over 2. Again, with a unit rate, we always divide by the denominator. So we're going to take 1/4 and divide it by 2. We're taking 1/4 and we're dividing it by 2. So if I do 1/4 and then divide it by 2, that's going to come out to the fraction 1/8, 1/8 completed per week. For problem 2, Camila filled a 4-gallon bucket in 1/6 of a minute. We want to know what is the speed that the bucket is getting filled at. So remember, speed is a measure, like a distance or a measure over time. It's always a measurement over time. So in this case, it's going to be how much did they fill over the time. So she filled 4 gallons in 1/6 of a minute. So that's what you would be setting it up as. 4 over 1/6. 4 over 1/6. What are we going to divide both values by now? What's our denominator? 1/6. So we're going to take 4 and we're going to divide it by 1/6. We're going to take 1/6 and divide it by 1/6. If you do 4 and divide it by 1/6, what do you get? 24. Good. So this is going to be 24 gallons per minute. 24 gallons per minute. Okay, problems 3 and 4, you're setting up 2 different rates. You're going to identify 2 different unit rates and then compare them. Go ahead and do problems 3 and 4 on your own. All right, let's take a look here. For problem 3, we have Publix fruit basket has 4 oranges and 8 apples. Kroger's has 3 oranges and 6 apples. We want to know if these are equivalent to each other, if they are equivalent ratios. So let's first start with Publix. Publix has 4 oranges compared to 8 apples. If I were to simplify this, if I were to simplify these ratios, this would simplify to what? They're both divisible by what? Yeah, 2 and 4, right? They both can be divided by 4. If I simplify them, that would come out to 1 orange for every 2 apples. I want to know, is Kroger's going to be the same? So let's take a look at Kroger. Kroger has 3 oranges and 6 apples. Those happen to both be divisible by 3. And that would come out to 1 orange for 2 apples. So are they the same? Yeah, they are equivalent. And guys, here's a really easy way to be able to tell too. What's 4 divided by 8? Do 4 divided by 8 right now. It's 0.5, right? 4 divided by 8 comes out to 0.5 or 0.50. What's 3 divided by 6? 0.5. They both come out to the same thing when you divide, don't they? They both come out to the exact same value, so that means that they are equivalent. These are equivalent. But for problem 4, Josh's pencil pouch has 12 pencils and 15 markers. Kyle's pencil pouch has 10 pencils and 12 markers. If we set these up, so for Josh, I'm going to set his up as 12 over 15. If I were to actually go ahead and divide, if I do 12 divided by 15, that's going to come out to 0.8. Now for Kyle, Kyle's is 10 over 12. 10 over 12. If I divide that out, that's going to come out to 0.83 repeated. Are those the same? No, this is not equivalent. That's not equivalent. Okay, I'm not going to worry about this last one because that's just another unit price problem that we've already done. I want to let you have time to work on your assignment. You've got about 20 minutes to be able to log into Google Classroom. Work on the Google Slides assignment first, the Let's Make a Deal assignment first before you do the IXLs.